pursuit of continuous quality education.
Living up to DepEd's mandate of no student should be left behind.
From the home of Sarongbangi,
The land of Oragons. This is Santo Domingo National High School. School on Air.
School on Air.
A blessed and safe day, our grade 9 students. It's nice to be with you again in this finale episode of our School on Air program for this school year. Once again, this is Ma'am Weng Balute, your radio teacher for Science 9, offering you different wavelengths to learn for varying concerns. I hope everybody has a healthy body and mind ready to catch and absorb as I project another mind-filling topic as we trudge the fourth quarter. I suppose you are now at the peak of the trajectory of your mood to learn at a place where you can hear me loud and clear. At this point, get your first module in Science 9 Quarter 4. Again, the first module in Science 9 for the fourth quarter. Have also with you a paper and a pen for you to take down some important notes as I discuss the lesson. Now, take a look at your module number 1 entitled The Horizontal and Vertical Motions of a Projectile. It contains lesson 1 and 2. The lesson 1 is all about projectile motion, and the lesson 2 focuses on the horizontal and vertical components of a projectile motion. Before we start, let me give you some reminders. To achieve the objective of this module, you have to do the following. First, take your time reading the lessons carefully. Second, follow the directions and or instructions in the activities and exercises diligently. And lastly, answer all the given tests and exercises honestly. Now please check whether you have given both lessons 1 and 2 in module 1. Lesson 1 starts from page 1 to 7 and lesson 2 is found from page 8 to 16. Are you fond of playing basketball, volleyball, soccer, or tennis? If yes, then our discussion for today will disclose some scientific explanation of the motion observed in these games. Are you now ready? So start your engine now, for we are about to take off and explore these lessons. In this module, you will learn the definition of projectile different from projectile motion. You will also learn on how to describe the horizontal and vertical motions of a projectile. And lastly, you can be able to explain horizontal and vertical motions of a projectile. Activities are provided for you for deeper understanding of the topic. From your previous academic years, you have learned that the 3 laws of motion, such as law of inertia, law of acceleration, and law of interaction, govern on moving objects traveling in either 2 of the straight lines, the horizontal and vertical motions. For this lesson, you will learn the definition of projectile motion and the terms that involves in it. Furthermore, you will learn that projectile motion consists of 2 motions. On page 2 of lesson 1, you will see figure 1.1, which illustrates 3 possibilities of motion of a ball if it is thrown by a man at a cliff. In the first figure, the ball travels diagonally. In the second figure, the ball seems to follow a curved path, while in the third figure, the ball travels horizontally. Which of the three situations is or are more likely to happen in real life? If your answer is figure 2, then you are correct. Figure 2 is the correct illustration of a motion of a ball that is projected in air. Once released, the ball is projected from a certain height, will not continuously move diagonally nor horizontally. Instead, it will travel as if it follows a curved path. Another situation is illustrated on figure 1.2, wherein a soccer player is kicking a rattan ball. In the situation A, the ball will move diagonally in air after kicking, while in situation B, the ball will travel in a curved path. What will be your observation as you look into the motion of the ball at a slow-paced time? Is it situation A or situation B? If your answer is B, you are again correct. The ball will move in a curved path. Now, what do you think would be the explanation for that? Stay tuning as I go through the discussion so that you would know the reason behind that kind of motion. In figure 1.3 on page 3 of lesson 1, the motion of the man as it dives into the water is moving along a curved path downward due to the natural force called gravitational force or gravity. If you can still remember, gravity is the natural force that causes objects to fall towards the earth. This is the reason why an object thrown will not stay steadily on air. Rather, it will go back to the ground. This is also the reason why we were able to stand stationary, because gravitational force acts on our body. Hence, the acceleration due to gravity is always directed downward. With this, the motion of the man in figure 1.3 undergoes projectile motion. Perhaps you are asking what a projectile motion is. It is a form of motion where an object moves in a curved path. The object that is thrown or projected and exhibits projectile motion is called projectile. Again, a projectile is an object undergoing a projectile motion. The curve-like path undertaken by a projectile is called trajectory. May I repeat? A trajectory is an arc or curve-like motion path undergone by a projectile. On page 4 of lesson 1 of your module, you will see figure 1.4. It illustrates the components of a projectile motion. These are the following. First, the projectile, which is the object undergoing projectile motion. Second is the trajectory, the parabolic or curved path taken by a projectile. And lastly, the angle of projection, which pertains to the numerical value in degrees expressing the orientation of the projectile to be thrown or projected. Since the projectile motion travels in a curved path, then this lesson can be best described using some mathematical concepts and terms. In figure 1.5 on page 4 of lesson 1, you will see a jumbled letter. Guess the mathematical term which is synonymous to a curved path. What is the mystery word in that figure? Did you get it? If you think it is parabola, then you are right. Excellent. An angled launch projectile exhibits a full parabolic trajectory motion. This shows that as the player kicked a rattan ball in the air, the ball will eventually go back to the ground still due to gravity as it moves horizontally. Hence, projectile motion consists of horizontal and vertical motion working independently. At this point, turn your module on Lesson 2 found on page 9. You will see there two figures contained in Figure 2.1. What do you think is the difference between the two figures? Perhaps you would say, though both motion shows a parabolic or curved path, but the first one started from a certain height. That is why its motion is a parabolic path projected downward, and the second figure shows a ball projected from the ground at a certain angle to a certain height, then it goes back to the ground. These two figures show the illustration of the two types of projectile motion. The first type is the horizontally launched projectile, while the second type is the angle-launched projectile. Let me discuss the detailed characteristics of each type. On page 10 of Lesson 2 of your module, you will see Figure 2.2, showing the schematic diagram of the first type, the projectile that is launched horizontally. The components of this type is also illustrated there. These are the following. First is the height, which pertains to the vertical distance from the ground up to the point where it was released. Second is the range, which is the horizontal distance covered by the projectile, or in other words, the distance from the foot where it was released to the point where the projectile landed. While the projectile is in the air, it has an instantaneous velocity. This is the velocity of the projectile at any point in the trajectory. Since the projectile is not traveling either horizontally or vertically, but at a certain angle along its way downward, its instantaneous velocity has horizontal and vertical components. These are the third and fourth components of the first type of projectile. The horizontal component of the velocity, or the Vx, is the one responsible for the projectile to travel at a horizontal distance. On the other hand, the vertical component of the velocity, or in symbol, the Vy, is the one responsible for the projectile to travel in a vertical distance. Based from Figure 2.2, you will see that the motion of the marble is gradually increasing from points A to D due to the presence of gravity accelerating at a rate of 9.8 meter per second squared, or sometimes it is rounded off to 10 meter per second squared. This causes the vertical velocity, or the Vy, to increase, which makes it not constant. For the horizontal velocity, there is no external force acting along the horizontal motion, which means acceleration does not exist, or Ax is equal to 0, resulting to a constant horizontal velocity, or the Vx. When you say constant, it does not change along its way. Hence, in Figure 2.1 on page 9, when the rider takes off from the cliff of its motion in increasing due to the presence of gravity, which accelerates the rider's vertical velocity at 9.8 meter per second interval. On page 11 of lesson 2 of the module, you will see figure 2.3, which shows the motion diagram of a baseball as it was hit by a bat. This illustration represents the second type of projectile, the angle-launched projectile. If you are going to compare it with the first type, you will see that the second type is projected at a certain angle with respect to the ground or surface where it was released. Thus, it has upward and downward motion. At this point, let me discuss the components of the type 2 projectile. These are angle, vertical and horizontal velocities, range, and maximum height. Let me discuss each. First is the angle, which is a numerical value in degrees expressing the orientation of a projectile to be thrown or projected. Another is the vertical velocity, or Vy, which is the y component of the instantaneous velocity that is responsible for the projectile to travel at a vertical distance. And the horizontal velocity, or Vx, is the x component of the instantaneous velocity that is responsible for the projectile to travel at a horizontal distance. We have also the maximum height. It pertains to the maximum vertical distance from the Earth's surface or point parallel to where the projectile is released up to the highest point the projectile has reached. Lastly is the range. It is the total horizontal distance the projectile has covered as it is in the horizontal distance from the point where the projectile has released up to the point where it landed. Perhaps you are thinking how the velocity of a projectile in the second type varies along its trajectory. Here is the explanation for that. For angle-launched projectile, horizontal velocity, or Vx, is still constant, while the vertical velocity can be described in three parts. From figure 2.3 on page 11, it is observed that as the projectile rises from point A to B, the vertical velocity, or the Vy, is decreasing. This is because the direction of gravity is opposed to the projectile motion. As the projectile reaches the maximum height, or point B, it momentarily stops, causing a vertical velocity to be equal to 0, or in symbol, Vy is equal to 0. When it returns back to the ground, from point B to C, it agrees to the direction of gravitational force. Hence, vertical velocity is increasing. So in figure 2.1 on page 9, the vertical velocity of the ball as it rises to the air decreases due to the opposing direction of gravity towards its motion. When the baseball reaches the maximum height, it momentarily stops, causing the vertical velocity to be equal to 0. When it reaches the ground, its vertical velocity increases, since the direction of the baseball's motion is the same with gravitational force. At this juncture, I want you to evaluate your own understanding on this subject matter. Kindly get a sheet of paper and a pen. Please turn your module on page 6 of Lesson 1 and answer Activity 1.2, Parts 1 and 2. Again, turn your module on Activity 1.2, Parts 1 and 2. For the first part, you are asked to identify if the given illustrations are projectile or not. Write check if it is a projectile and X if it is not. And for the second part, still on page 6, you are asked to classify the given sports or games as to projectile or non-projectile. You are going to copy the table and write your answers on the designated column. I am giving you 2 minutes to answer these. Your timer starts now. Are you through? Now please check whether your answers are correct. Give 1 point for every correct answer. For the first part, the answers are as follows. For number 1, the illustration is not a projectile, so the answer should be X. For number 2, the answer is check, since the illustration shows a projectile motion. For number 3, the correct answer is X. For numbers 4 and 5, the answer is both check. Did you get it perfect? You are amazing. For part 2, you are going to give yourself 1 point for every item that is correctly classified. The sports or games classified as projectile are as follows. A volleyball being served. A motocross taking off from the cliff. A flight of a soccer ball. A smashing of shuttlecock. A baseball hit by a bat. And the slice serving of the ping pong ball. There are 6 items classified in it. For the non-projectile sports or games, we have the following: car racing, 100-meter dash, dragon boat paddling race, and short course swimming. So there must be 4 checks for this group. The total items for parts 1 and 2 is 15. How's your score? Is it perfect? Excellent. This time, determine the level of your understanding on Lesson 2. Please turn your module on page 12 and answer the activity 2.1. Read and understand each statement carefully. You write true in your answer sheet if the given statement is correct And if it is false, change the underlined word or phrase to make the statement correct. Have it all answered within 2 minutes. You may start it now. Your time is up. Give 1 point for every correct response in this part. Now, let us check your work with these key answers. For number 1, the answer is 0. Number 2, true. Number 3 is decreases upward. 0 on top and increases downward. Number 4, the answer is true. Number 5 is 0. Number 6 is true. Same with number 7, true. Number 8 is 9.8 meter per second squared or 10 meters per second squared. Number 9 is increases. And number 10, no external force. Are you perfect in this part? Wow, you are great. This time, let us proceed to activity 2.2 on page 13 of lesson 2. In this activity, you are instructed to identify and label the specified components such as height, range, vertical velocity, horizontal velocity, and angle to make the given diagrams complete. Write the answer in your paper. A minute will be given to you for this part. Your 1 minute starts now. Okay, a minute is over. So please check your answers. For number 1, the answer is horizontal velocity, or you can indicate there the symbol, which is the Vx. Number 2 is vertical velocity, or in symbol Vy. Number 3 is height. Number 4 is range. Number 5, horizontal velocity, or that is Vx. Number 6, vertical velocity, or Vy. Number 7 is height. Number 8 is angle, or you can also indicate there the symbol for angle. And we have number 9, range. The highest possible score here is 9. So you just add 1 to your score to make it 10. So congratulations for persistently answering it. To strengthen your understanding on this topic, the following activities are expected to be answered completely in your answer sheet, since this will be credited as your performance output. So these are activities 1.1 on page 5 of lesson 1, activity 1.3 on page 7 of lesson 1, activity 2.3 on page 14 of lesson 2, and activity 2.4 on page 15 of lesson 2. I will personally check your answers in this part. So a minute will be given to you to do this task. Anyway, you are just going to sketch in this part. Okay? Your time starts now. May I remind you that your answer sheet will be passed tomorrow during our schedule for modules retrieval. So, you have to do all the activities that is given to you, all of your subjects, since that is the last schedule for the retrieval. So may I also remind those who are not yet, those who have incomplete submission in the previous activities, to pass it also tomorrow during our schedule. And for my advisory class, the 9 Diamond, please do the submission punctually. Okay? We are about to end our episode for today. I am grateful that you have showed your willingness and enthusiasm to learn all throughout our RBI episodes. Definitely, I will seal this last episode with a smile of inspiration and hope that next school year will be a better one for all of us. Again, this is Ma'am Weng Balute, your teacher broadcaster for Science 9, saying, what you do will make a difference. Keep safe, always follow health protocols, and together, let us heal our land. Goodbye!